we are going to understand Labyrinth Escape AI. Now I'm going to show how BFS works to find a way in the Labyrinth Maze. So this is a grid view of the labyrinth or maze. So my initial point would be 0, 0, and my goal is to reach 4, 4. And I'm going to show how we use BFS in this scenario. So since this black dot that you see at node 0, 1 or 1, 1, these are the walls, static points that we can't, so these walls show static point that we can't cross, and the green dots that you see is the clear path that we can follow to reach the goal state. So this is simple like a maze. So we'll start with step 1. We will have a queue of the nodes which we are going to expand. So first would be the initial point, of course, initial node, and we will also have to keep track of the visited nodes. So initially we have not visited any nodes, so we'll start by visiting the first node. That is, we will pick 0, 0 from the queue and expand it. Okay, so what are the neighboring nodes of 0, 0? We have an option in the down which is 1, 0. And when we can't explore the right node, which is this one, 0, 1, because this is a wall, of course we can't go there. So now we will add the node in the queue, the next neighboring node which we found of 0, 0, which is 1, 0 in the queue to explore further, and the visited count would be, simply we will add the expanded nodes here since we have visited it. Step 3 would be to expand the next node, which is from the queue we will pick, which is 1, 0. 1, 0, we will only have one option, that is down, is 2, 0. And my queue will have 2, 0 as the next node to explore. Okay, and the visited count would be, expanded 0, 0, and the next one is simply 1, 1, the recent node that we expanded. So now step 4 is to expand the next node. I will simply write E for denoting expanding the node. So we'll pick 2, 0 from the queue and expand that. So we have option of down, which is 3, 0. The node, this one we can expand 2 zeros immediate neighbor, which is at the down we have 3, 0. And immediate to the right we have 2, 1. To the right we have 2, 1. So in the queue, simply I will write Q to denote the queue. In the queue we will have to add 2, 1 and 3, 0. Okay, now the visitor nodes would be, simply we will write 0, 0 and 0, and the recent one that we expanded. Step 5 would be the expanding the node which is in the queue right now, the first one which is 2, 1. We're going to expand that. So 2, 1 immediate neighbor to the right we have 2, 2, and since we don't have any other options, like we can't go down to 3, 1, which is a wall, of course, we'll simply just add this to the queue. So since we remove 2, 1, we need to write 3, 0 at the front, and to the right we will have 2, 2. the visited count would be simply 0, 0, 1, 0, 2, 0, and expanded one to 1. Step 6 would be to expand the next one in the node, which is in the queue. We have 3, 0. So expanding 3, 0, we will only have one option, which is 4, 0 to the down. And my queue would now contain after 2, 2, 4, 0. And the visited would be the rest of the I'm not going to write all, so I'm going to write this and then recent that we expanded 3, 0. Now step 7 would be expand the next one, which is 2, 2. So 2, 2, we have just one above option, which is 1, 2, and the queue would now contain after 4, 0, 2, 2, sorry, 1, 2. You only have one option, which is 1, 2, and the visited nodes would be the rest of the list, and 3, 0, and 2, 2. The recent one that we expanded to 2. Alright, after this we are done. So I would also like to keep check on the nodes by writing V here. So we have visited this, we visited this. Alright, yeah, so we also visited this one, 3, 0, and 2, 2, 2, sorry, 2, 1, and 2, 2 also we have visited. Okay, now the next one would be 4, 0 that we are going to visit. So I'm going to erase some of the part. So step 8 would be to expand the next one, which is 4, 0. So we have immediate neighbor as right to 4, 0. We have 4, 1, and simply just add this in the queue after 1, 2, 4, 1. Okay, we still not reached the goal state, so we'll continue this. So this would be the list right now: 0, 0, 1, 0, 2, 0, 2, 1, 3, 0, and 2, 2. Also, we will write this that we recently expanded, which is 4, 0. Okay, we have written all. Now we will explore the next node in the queue, which is 1, 2. So after expanding 1, 2, we have one option which is up. Sorry, it would be up. So up option which is 0, 2. So simply add this in the queue after 4, 1. We have 0, 2. And the visitor would be last of the list, and 1, 2 that we recently expanded. Step 9 would be, sorry, step 10 would be expand 4, 1. So I will also have to write this here. Visited one, I visited this. 0, 2 has not been yet visited, and this is visited. So my AI is going through like this and this part, both the directions to reach the goal state right now. So yeah, step 10 would be to expand 4, 4, 1. We have immediate option to the right, which is 4, 2. And Q would be 0, 2, 4, 2. And the rest of the list and expanded one, which is 4, 1. So the 11th step would be to expand the next one, which is 0, 2. After expanding 0, 2, we only have one option, which is to the right, 3, 0, 3. We'll add this in the queue. After 4 1, after 4 2, we have 0 3 as a option. Will be the rest of the list, and 0 2. And step 11 would be to expand. Sorry, step 12 would be to expand the next one, which is after 4 2. So 4 2 is expanded right now. So the queue would now be updated to, sorry, after, if we expand 4 2, we have option as 4 3. So 4, we are reaching very close to the goal state, as you can see. So to the right of 4 3, and the queue would be now 0 3, and after that 4 3. So visited would be the rest of the list, and then it would be the expanded one. Step 13 to expand the next one, which is 0 3. So 0 3, we only have one option to the right. 0 4, the queue would now become 4 3 0 4, and the visitor would be the rest of the list, and 0 3. Also like to mark here the visitor nodes. I visited this, 4 2 has been visited, here we have visited this, and 0 3 also has been visited just right now. So yeah, now we're going to expand 4 3, so we will say this is also visited. Okay, so step 13 is done. So we'll move to step 14. Step 14 would be to expand the next one in the node, which is 4 3. So if we expand that, we will reach to the goal state, which is 4 4. We have not yet visited it, but we will add this in the queue. So my queue will now contain 0 4 and then 4 4. Visited would be the rest of the list, and the recent expanded node, which is 4 3. Okay, so step 15 would be to expand 0 4, and to bottom we have node option as 1 4, and the queue would now contain 4 4 and 1 4. The visitor would be rest of the list and current expanded node, which is this one. Now step 16 is now going to be our goal state, expanding that, which is 4 4, which is the next one in the queue. So since we reached this goal state, we don't need to further expand it since we have reached the goal state. Okay, so we will mark the things that we have visited, and we visited this also, and we finally reached it. So the path is something like this. So let me show you the program in Python, how it looks. So this is the program in Python for the same. I've used a grid system to visualize it, and this is the path we found, which is similar to this: 0 0 1 0 2 0 3 0 4 0 4 1 4 2 4 3 4 4. It is exactly same. Okay, 0 0 0 1 0 2 0 3 0 4 4 1 4 0 4 1 4 2 4 3 4 4. Okay, so my goal state is raised using BFS. Now let's see a pictorial representation via HTML code. So this is the path. This is how it is working. We followed the exact same thing. Starts with expanding in both direction, and then when we reach the goal state, we consider this as the optimal path, best shortest path for reaching the goal state. So that would be all for the video, and I hope you guys understood how BFS works in solving and navigating through a labyrinth maze. Thank you.